Hello, in this lecture we find out the ratio of B over A. In the drawing we have a big circle. Inside this big circle we have two smaller circles. And we also have a right triangle that is partially located inside the big circle. We know that the radius of this circle is equal to B units in its length. The radius of this circle is equal to A units in its length. In addition, we know that side AB of triangle ABC equals to 5 units in its length. Side BC of triangle ABC equals to 12 units in its length. And we also know that AN equals to NC. Our mission is to find out the ratio of B over A, that is to say, the ratio between the radii of those two circles that are located inside the big circle. So first of all, we will focus on the right triangle ABC, and we implement the Pythagoras theorem on the right triangle ABC. Again, this angle equals to 90 degrees. Angle ABC equals to 90 degrees, therefore triangle ABC is a right triangle. So we will implement the Pythagoras theorem on the right triangle ABC. So according to the Pythagoras theorem in the right triangle ABC, by PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and must be equal to AB square plus BC square. Repeat again. According to the Pythagoras theorem, in the right triangle ABC, AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5 according to what is given as the equation, therefore AB square is 5 squared, that is 25, plus BC square. BC is 12 according to what is given as the equation, therefore BC square is 12 squared, that is 144. So we found out that AC square equals to 25 plus 144 is 169. We will take a root out of this equation, and we get that AC equals to the square root of 169, it is 13. So AC, the hypotenuse AC equals to 13 units. This hypotenuse AC equals to 14 units in its length. But we know that AN equals to NC. So at point N, the hypotenuse AC is bisected into two halves. So it means that AC over 2, AC is 13 over 2. Each half of the hypotenuse AC, the first half is AN and the second half is NC. So AC over 2 equals to AN, the first half, and it is also equals to NC. NC is the second half of the hypotenuse AC. So actually, we found out that AN, it is given us the equation that AN equals to NC. AN is the first half and C in the second half, and each half equals to, of the hypotenuse AC equals to 13 over 2. AN equals to NC equals to 13 over 2. So you can write here that line segment NC equals to 13 over 2 units in its length, and line segment AN also equals to 13 over 2 units in its length. In the next step, I will present to you a new rule, rule number 8, and we will implement rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle, R is the radius, it is equals to, here we have triangle ABC, right triangle ABC, that blocks this circle. So we can know the radius of this circle only by knowing the sides of the right triangle ABC. You know that the length of side AB is A units, side AB equals to A units in its length, side BC, the perpendicular BC equals to B units in its length, and the hypotenuse AC of the right triangle BC it is equals to C units in its length. So according to rule number 8, the radius of this circle that is blocked by this right triangle R will be equal to A plus B, that is the sum of the lengths of the perpendiculars, A plus B, the perpendiculars of triangle ABC, minus the hypotenuse, the length of the hypotenuse is C, so it is minus C over 2. Okay, so the radius of this circle R equals to A plus B minus C over 2. You can implement rule number 8 in our drawing. Why? Because in our drawing we have this is the right triangle ABC that blocks this circle, and we know that the radius of this circle equals to A. According to rule number 8, the radius of this circle A will be equal to the length of the two perpendiculars, that is to say AB plus BC. AB is 5, BC is 12, so it is 5 plus 12, minus the length of the hypotenuse, that is 13, over 2. Okay, actually this equation is the implementation of rule number 8 in our drawing. Again, the radius A equals to the sum of the lengths of the two perpendiculars, that is 5 plus 12, that is 17, minus the length of the hypotenuse, that is 13, over 2. 17 minus 14 is 4, and 4 over 2 is 2. So in conclusion, found out that the radius A of the small circle equals to 2 units in its length. A equals to 2 units in its length. We also have rule number 1, that a tangent to a circle is perpendicular to the radius drawn to its point of tendency. We define the center of this circle as P. We define the point of tendency of tangent AB with this circle as T. We join points T and P together by a straight line. Point P is the center of the circle. Point T is the point of the circle itself. Therefore, PT is the radius of the circle. That is A, that is equal to 2 units. So, the radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle, and then we have a radius that is drawn to the point of tendency. Then, according to rule number 1, this angle will be equal to 90 degrees, and this angle equals to 90 degrees. Okay? I will not repeat on rule number 1 because we actually talked about it in the previous lecture. So here we have tangent BC is tangent to this circle at point N. We define the point of tendency as N. We join points P and N together by a side line. Pn is the radius of the circle that is equal to 2. Again, the radius Pn is drawn to point N, that is the point of tendency of tangent BC with the circle, and then we have a radius that is drawn to the point of tendency. Then tangent BC will be perpendicular to the radius NB, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees, according to rule number 1. So in quadrilateral TPBN, we have 1, 2, 3 right angles. This is the angle of the right angle ABC that is equal to 90 degrees. So we have 1, 2, 3 right angles. The sum of right angles is 270 degrees, plus the fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be also equal to 90 degrees. So here, quadrilateral BTPN has 4 right angles, 1, 2, 3, 4. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral TBNP as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say Pn equals to TB. Pn equals to TB, but Pn is 2, therefore TB is also 2. And according to the same rule that the opposite sides of a rectangle are equal to each other, we get that Tp equals to Bn. Tp equals to Bn, but Tp is 2, therefore Bn must be also equal to 2. So actually we found out that in quadrilateral TPBN we have 4 right angles and 4 equal sides. All those 4 sides are equal to 2, therefore quadrilateral TPBN is a square. Because all of the sides are equal to each other. So here we found out that TB equals to 2, AB is equal to 5 units according to what is given us in the question. So AB minus TB equals to 80. Repeat again. AB minus TB equals to 80. Okay? AB minus TB equals to 80. AB is 5, TB is 2. So 80 equals to 5 minus 2, that is 3. So found out that 80 equals to 3 units in its length. 80 equals to 3 units in its length. Here we have rule number 2. I'll repeat on it very quickly. The lengths of two tangents from a common external point to a circle are equal. We have the common external point, point A. From the common external point, point A, we have two tangents to this circle, tangent AT and tangent AM. According to rule number 2, they are equal to each other. That is to say, AT equals to AM. But AT is 3, therefore AM must be also equal to 3. Okay. We have already found out that AN equals to 13 over 2. AM is 3, therefore AN minus AM equals to MN. And repeat again. AM minus AN minus AM equals to MN. I repeat again, AN minus AN minus AM equals to MN. Repeat again, AN minus AM equals to MN. AN is 13 over 2, AM is 3, and it equals to MN. So here we multiply 3 by 2, and then we divide it by 2 in order to overcome 4 over 13 over 2. So it is 13 over 2, 4 times 2 is 6, so it is 13 minus 6 over 2. 13 minus 6 is 7, so in total this expression equals to 7 over 2. So that is to say Mn equals to 7 over 2 units in its length. Mn equals to 7 over 2 units in its length. Here, Mn, this line segment Mn equals to 7 over 2 units in its length. Okay. So, in the next step, we'll define the center of the biggest circle as O. This is the center of the circle, the biggest circle that we'll define as O. Here we have rule number 7. According to rule number 7, if a line segment that is drawn from the center of a circle bisect a chord, then the line segment is perpendicular to the chord. Point O is the center of the circle, so we draw line segment OM, and it is given us here in the sentence that OM bisects AB. That is to say, OM divides AB into 2 equal parts. That is to say, AM equals to MB. AM equals to MB. And because of the fact that line segment OM bisects AB, that is AM, that is to say AM equals to MB, then according to this rule number 2, OM also is perpendicular to AB. OM is perpendicular to AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. You can implement rule number 7 in our drawing. Here, point O is the center of the circle, the biggest circle. We join points O and N together by a straight line N. At point N, chord AC is bisected into 2 halves. Okay? Here, because of the fact that AN equals to NC, it means that at point N, chord AC is bisected into 2 halves. So we join the points O and N together by a straight line. Again, because of the fact that line segment ON bisects chord AC because AN equals to NC, it means that ON is also perpendicular to OC. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule number 7. Okay. We will define the center of this circle as Q. It is given us the question that AC is tangent to this circle at point N. So here actually QN is the radius of this circle. Again, QN is the radius of this circle. Why? Because line segment QN starts from point Q, that is the center of the circle, and ends at point N, that is the point of the circle itself. This is exactly the definition of a radius. The radius QN of this circle is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, according to rule number 1, a tangent AC is perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees, according to rule number 1. So you can write down that ON is perpendicular to AC. According to rule number 7, ON is perpendicular to AC. ON is perpendicular to AC. But we just right now found out that QN, the radius QN, is also perpendicular to AC. According to rule number 1, QN is also perpendicular to AC because the radius QN is drawn to point N, that is the point of tendency, therefore tangent AC will be perpendicular to QN. So we can write down that QN is also perpendicular to AC. Okay, so ON is perpendicular to AC and QN is also perpendicular to AC. So from those two equations we will derive that point O is located on QN. Point O must be located on this line segment QN, on the radius QN. Why? Because if point O is not located on QN, it means that ON will not be perpendicular to AC. Only and only if point O is located on QN, only then ON will be perpendicular to AC. Otherwise, ON will be never perpendicular to OC. In order that ON will be perpendicular to AC, point O must be located on QN. That is to say, QON is one straight line. Okay, QON is one straight line. Line segment QN is one straight line. Or in other words, points Q, O, and then all of them they are located on the same straight line. QON is one straight line. We'll draw. This is the point of tendency. If we draw here tangent VW is tangent to both circles. At point U, tangent VW is tangent to this circle and it is also tangent to the biggest circle. So actually here the radius QO is drawn to point O, that is the point of tendency of tangent VW with this circle. And whenever you have a radius, the radius B, that is drawn to point of tendency, then according to rule number 1, this angle equals to 90 degrees and this angle equals to 90 degrees. So can write down that QO is perpendicular to VW. QO is perpendicular to VW. But we also know that VW is tangent to the biggest circle. Again, tangent VW is tangent to the biggest circle at point O. This point U. And therefore, the radius OU of the biggest circle is drawn to point O, that is the point of tendency of tangent VW with the biggest circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius OU. So can I note that OU is also perpendicular to VW. OU is also perpendicular to the tangent VW. Okay. Repeat again. QU is perpendicular to VW, and OU is also perpendicular to VW. So, from those two equations, we will derive that OQU are located on the same straight line. Okay, OQU, line segment OQU, line segment OQO, is one straight line. That is to say, all the 3 points O, Q, and U, they are located on one straight line. One straight line. Why? Because if O, Q, and U, they are not located on the same straight line, then either one of the two, either O or U will not be perpendicular to VW, or QU will not be perpendicular to VW. If those 3 points O, Q, and U, they are not located, all of them on the same straight line, then either QU will not be perpendicular to VW, or OU will not be perpendicular to VW. So in order that both of them, OU and QU, both will be perpendicular to VW, all the 3 points O, Q, and U must be located on the same straight line. Okay, so actually found out that OQU is located on the same straight line, and QON, those 3 points, they are also located on the same straight line. Therefore, and QN is the radius of this circle that is equal to B. Actually, we can derive from all the things that we did until now that UN is the diameter of this circle that is equal to 2B. UN is the diameter of the circle and the diameter of the circle equals to 2b. The diameter of the circle equals to 2b, 2 times the radius. Okay? UN is the diameter of the circle that is equal to 2b. Okay? So in the next step, we join the center of the biggest circle with the center of this circle. That is to say, we join points O and P together by a straight line. So the smallest circle has an internal notch with the biggest circle. I repeat again, this smallest circle have an internal notch with the biggest circle. That is to say, those two circles, the smallest circle and the biggest circle, are touching each other at this point. We define the touching point as S. Okay, I repeat again, this smallest circle and the biggest circle touch each other at point S. This is their touching point. And we have all number 9. According to all number 9, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. The center of the big circle is at point O, the center of the small circle is at point M. Those two circles have an internal notch between them at point P. That is to say that they touch each other internally at point P. Point P is their touching point. The straight line that connects their centers together is OM. And according to this rule number 9, the straight line OM must pass through point P. That is to say, OMP is one straight line. Or in other words, all the 3 points O, M, and P, they are all located on the same straight line. Again, O and P is one straight line. Okay? We can implement rule number 9 in our drawing. Why? Because in our drawing, the small circle touches the biggest circle at point S. And according to rule number 9, whenever we have an internal notch between two circles, then the straight line that connects the centers together, that is to say OP, must pass through point S, or OPS is one straight line. Okay, according to rule number 9, OPS is one straight line. So if OPS is one straight line, OPS is one straight line, so you can conclude from it that OS minus PS equals to PO. Again, OS minus PS equals to PO. OS minus PS equals to PO. Okay? Because of the fact that OPS is one straight line, you can conclude from it that OS minus PS equals to PO. OS minus PS equals to PO. OS is the radius of the biggest circle. Why? Because point O is the center of the biggest circle and point S is the point of the biggest circle itself. This is exactly the definition of a radius. We define the radius of the biggest circle as x, so we can substitute OS by x minus PS. PS is the radius of the small circle. Why? Because I say that PS starts from point P, that is the center of the smallest circle, and ends at point S, that is the point on the smallest circle itself. Therefore, PS is the radius of this circle, small circle, that we found out that is equal to 2 units. So PS is 2, so we substitute PS by 2. So in conclusion, we found out that PO equals to x minus 2. This line segment PO equals to x minus 2 units in its length. Okay. In the next step, we will extend QN, the radius QN, by a straight line. This angle equals to 90 degrees. We extended the straight line QN by a straight line, therefore the result is a straight line. So if you focus on this side of the straight line, this straight line at point N, this angle equals to 90 degrees, plus the missing angle, in total they must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. Okay. AC, side AC is tangent to this circle at point M. So, if we join points P and M together by a straight line, PM is the radius of this circle. Why? Because it starts from point P, that is the center of this circle, and ends at point M, that is the point on the circle itself. This is exactly the definition of a radius. The radius PM is known from point M, that is the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees, and this angle is also equals to 90 degrees. In the next step, from point P, so we draw perpendicular on PN on point P. Okay, we have here the radius PM. On PM, we will draw perpendicular at point P. So actually, this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular with the extended QN as T. Inside quadrilateral MNTP, we have 1, 2, 3 right angles. Therefore, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, the missing angle here must be equal to 90 degrees. So, any quadrilateral that is equal to 300, we have 1, 2, 3, 4 right angles in quadrilateral and MNTP. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate quadrilateral PMNT as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, MN equals to PT, but MN is 7 over 2, therefore PT is also 7 over 2. Likewise, in rectangle MNTP, PM is the radius of this circle that is equal to 2 units. PM equals to the opposite sides TM in rectangle MNTP. But PM equals to 2, therefore TM must be also equal to 2. We define NO as h, that is to say the length of NO is equal to h according to our definition. Then we focus on the green right triangle PTO. We'll implement the Pythagoras theorem on the green triangle PTO. In the green triangle POT, according to the Pythagoras theorem, by PT is the abbreviation for Pythagoras theorem. In any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is PO, therefore the square of the hypotenuse is PO square. And it must be equal to PT square plus TO square. Repeat again. In the right triangle POT, according to the Pythagoras theorem, PO square equals to PT square plus TO square. We have already found out that PO equals to x minus 2. So we can substitute PO in this equation by x minus 2. If PO equals to x minus 2, it means that PO square equals to x minus 2 square. That is equal to PT square. We found out that PT equals to 7 over 2, therefore PT square equals to 7 over 2 square. Plus TO square. TO in total equals to 2 plus h. Again, TO equals to 2 plus h. Therefore, TO square equals to 2 plus h square. So in conclusion, we found out that x minus 2 square equals to 7 over 2 square plus 2 plus h square. So we open the brackets on both sides of the equation and we will get that x minus 2 square equals to x square plus 2 squared, that is 4, minus 2 times 2x is minus 4x, and it is equals to 7 over 2 square is 49 over 4, plus 2 plus h square. 2 plus h square equals to 2 squared, that is 4, plus h squared plus 4h. Okay. We join points O and C together by a straight line. Point O is the center of the biggest circle. Point C is the point of the biggest circle itself. This is exactly the definition of a radius. So OC is the radius of the biggest circle, that according to our definition, it is equals to x. We'll focus on the right triangle ONC. So I copy the right triangle ONC here. The hypotenuse OC is equal to x. ON equals to h according to our definition. NC equals to 13 over 2. AN equals to NC, each of the halves, one half, equals to 13 over 2 units. In total, AC equals to 13, therefore each half equals to 13 over 2. So NC equals to 13 over 2. We will implement the Pythagoras theorem on this right triangle, and we get that x squared equals to h squared plus 13 over 2 square equals to 169 over 4. So in conclusion, we found out that x squared equals to x squared plus 169 over 4. Now we'll substitute x squared in this equation by h squared plus 169 over 4. And we'll get that, so here, x squared is h squared plus 169 over 4 plus 4 minus 4x is equals to 49 over 4 plus 4 plus h squared plus 4h. Okay. So here we have h squared on both sides of the equation, so h squared will get cancelled. Here we have also 4 on both sides of the equation, so 4 will also get cancelled. In this side of the equation we have 169 over 4. We subtract from this equation 49 over 4, so it is minus 49 over 4. We will add to this equation 4x, so it will be 4x plus 4h. 169 minus 49 is 120, so this expression in total equals to 120 over 4. That equals to 4, we take a common factor of 4, so inside the brackets we have x plus h. 120 over 4 is 30, so 30 equals to 4 times x plus h. We divide this equation by 2, and we get that 30 over 2 is 15. Equals to 4 over 2 is 2, plus x plus h. We divide this equation by 2, and finally we get that x plus h equals to 15 over 2. The conclusion found out that x plus h equals to 15 over 2. Okay. What is actually x plus h? OU is the radius of the biggest circle, that's equal to x. ON is h. That is to say, ON equals to OU. Again, this line segment in total, NU equals to NO plus OU. OU is x and ON is h, so in total NU equals to x plus h. NU, line segment NU equals to h plus NU equals to x plus h. From one side, NU equals to x plus h, but from the other side, we have already found out that NU is the diameter of this circle, is equal to 2b. Okay. I'll show here. NU is the diameter of the circle that is equal to 2b. NU is b plus b, that is 2b. So NU from the other side is equals to 2b. So from this equation, we derive that x plus h equals to 2b, but x plus h equals to 15 over 2 also, so we can write down here that x plus h equals to 15 over 2, and from this equation we derive that 15 over 2 equals to 2b, we divide this equation by 2, And finally we get that b equals to 15 over 4. So we actually found out that b equals to 15 over 4. And we already found out that a, that is the radius of the small circle, is equals to 2. Therefore b over a will be equal to 15 over 4 over 2. 15 over 4 over 2, it is 15 over 8. So in conclusion we found out that b over 8 is equal to 15 over 8, that is 1.875. So the ratio of b over a is equal to either 15 over 8 or it is equal to 1.875. It is without units at all. Well, it is ratio, it is without units. So b over a equals to either 15 over 8 or in terms numbers it is equals to 1.875. Okay, and that is the answer to our question. In the next step I will summarize the lecture. So in this lecture I found out the ratio of b, that is the radius of this circle, over a, that is the radius of the smallest circle. So in the drawing we have this big circle. Inside this big circle we have those two circles, and also inside this the big circle we have triangle, the right triangle ABC, that is partially located inside this the biggest circle. Angle ABC equals to 90 degrees. Side AB of triangle ABC equals to 5 units in length. Side BC equals to 12 units in length. In addition, we know that line segment AN equals to line segment NC. Again, our mission is to find out the ratio of b over a, that is the ratio between the two radii of those two circles. So first of all, we implemented the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC. Therefore, AC square equals to AB square plus BC square. Repeat again. In the right triangle ABC, AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 square, that is 25, plus BC square. BC is 12, therefore BC square is 12 square, that is 144. So in total we found out that AC square equals to 25 plus 144. 25 plus 144, it is 169. So AC square equals to 169. We took out of this equation and we found out that the square root of 169 is 13. So AC equals to 14 units in length. This line segment AC equals to 13 units in length. But we also know that AN equals to NC. That is to say, at point N, line segment AC is bisected into two halves. The first half is AN and the second half is NC. Of course, AN equals to NC. So AC over 2, it is 13 over 2, that is equal to AN is the first half, and is equal to the second half, that is NC. Okay, so AN equals to NC equals to 13 over 2. Each half equals to 13 over 2. Okay. Then I presented to you rule number 7, rule number 8, and we implemented rule number 8 in our drawing. According to rule number 8, the radius of a circle that is the radius of a circle that is bisected by a right triangle the radius of a circle that is blocked by a right triangle. Here we have the right triangle ABC. The right triangle ABC blocks this circle. Angle ABC equals to 90 degrees. Side AB equals to units in its length. Side BC equals to B units in its length. And the hypotenuse AC equals to C units in its length. Then we can find out the radius of this circle that is blocked by this right triangle only by knowing the lengths of the sides of the right triangle ABC. That is to say, the radius of this circle R will be equal to A plus B, that is the length of the perpendiculars, the sum of the lengths of the perpendiculars, minus the length of the hypotenuse AC that is equal to C over 2. So R equals to A plus B minus C over 2. We can implement rule number 8 in our drawing. Because in our drawing we have triangle, the right triangle ABC blocks this circle, and according to rule number 8, the radius of this circle that is defined as A will be equal to AB plus BC minus the hypotenuse AC over 2. AB equals to 5 units, BC equals to 12 units, and the hypotenuse AC equals to 13. So it is 5 plus 12 minus 13 over 2. 5 plus 12 is 17, 17 minus 13 is 4. So A equals to 4 over 2, that is 2. So found out that the radius A equals to 2 units in its length. In the radius of this circle, A equals to 2 units in its length. Then we implemented in this circle the rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Your point P is the center of this circle. AB is tangent to this circle point T. We join points P and T together by a straight line. Point P is the center of the circle, point T is the point of the circle itself. Therefore, PT is the radius of the circle, that is equal to 2. The radius PT is drawn to point T, that is the point of tendency. Therefore, according to rule number 1, whenever a radius that is drawn to the point of tendency, then this angle equals 90 degrees and this angle equals 90 degrees. Likewise, we have BC is tangent to this circle at point N. We join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NQ. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So inside for the round PT PTBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle. In total, it must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. So, inside quadrilateral TPBN, we have 1, 2, 3, 4 right angles. Any quadrilateral the test for right angles must be a test rectangle in flattest curve. So we'll write to quadrilateral TPBN is a rectangle, and you know the opposite sides of rectangle are equal to each other. That is to say, PT equals to BN, but PT is 2, therefore BN is also 2. Likewise, PN equals to TB, but PN is 2, therefore TB must be also equal to 2. Therefore, actually, we have all the sides of quadrilateral TB and P, they are equal to each other. They are all equal to 4, and all of its angles they are right angles. Therefore, quadrilateral TBN is not a rectangle but a square, because all of its sides are equal to each other. So here TB equals to 2, AB equals to 5, AB minus TB equals to 80. AB is 5, TB is 2, so 5 minus 2, it is equal to 80, that is 3. We have rule number 2, that the lengths of two tangents from a common start point to a circle are equal. From the common start point A, we have two tangents to the circle, tangent AT and tangent AN, and according to rule number 2, they must be equal to each other. AT equals to PM, but AT is 3, therefore PAM must be also equal to 3, equals to 3. And here we found out that AN equals to 13 over 2, AM equals to 3, therefore AN minus AM equals to MN. Again, AN minus AM equals to MN. AN is 13 over 2, AM is 3, therefore MN equals to 13 over 2 minus 3, that is 7 over 2. So MN equals to 7 over 2 units in its length. Okay, and in the next step we define the center of the biggest circle as O, and here point O is the center of the circle, the biggest circle, and then we have here rule number 7, according to rule number 7, if a line segment that is drawn from the center of the circle bisects a chord, then the line segment is perpendicular to the chord. The center of the circle is here at point O. We have here chord AB. Line segment OM bisects chord AB. That is to say, it divides it into two halves. That is to say, AM equals to MB. And whenever you have from the center of the circle line segment that bisects the chord, then the line segment OM will be also perpendicular to AB. If OM is perpendicular to AB, it means that this angle equals to 90 degrees and this angle equals to 90 degrees, according to this rule, rule number 7. And implement rule number 7 in our drawing. From the center of the biggest circle, that is to say from point O, we join points O and N together by a set line. So we have line segment ON that bisects chord AC. Why? Because AN equals to NC. It means that line segment ON bisects chord AC. And whenever we have from the center of the circle a line segment that bisects a chord, then the line segment ON will be also perpendicular to AC. So if ON is perpendicular to AC, it means that this angle equals to 90 degrees and this angle equals to 90 degrees, according to rule number 7. Okay. So here we have AC is tangent to this circle is point N. Again, AC is tangent to this circle is point N. So if we join points Q and N together by a straight line, Q is the center of the circle, N is the point of the circle itself, therefore Qn is the radius of this circle that is equal to B units in its length. The radius Qn is drawn to point N, that is the point of tendency. of tangent AC with this circle, and whenever we have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So we can write down that QN is perpendicular to AC according to rule number 1. But ON is also perpendicular to AC according to rule number 7. Okay, this is according to rule number 1. And according to rule number 7, QN is perpendicular to AC. Again, both those line segment ON and QN are both perpendicular to AC. From those two equations, we derive that point O is located on QN. Again, point O is located on this line segment QN. Otherwise, ON will not be perpendicular to AC. Only if point O is located on QN, only then ON will be perpendicular to AC. Therefore, again, we must conclude that point O is located on QN, or QON, points Q, O, and N, they are all located on those 3 points, are located on the same straight line. QON is one straight line. Okay. Then, at point O, this circle touches the biggest circle. So we go tangent P with tangent VW, tangent to both circles at point O. Point U is point of tendency of tangent VW with both circles. Okay. So here we have Q is the center of the circle, U is the point of the circle itself, therefore QU is the radius of this circle is equal to V units in its length. So the radius QU is drawn to point O, that is to point U, that is the point of tendency of tangent VW with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to UQ. If VW is perpendicular to UQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So you can write down that QU, radius QU, is perpendicular to tangent VW. But here we have point O is the center of the biggest circle. Point U is a point on the biggest circle itself. Therefore, OW is the OU is the radius of the biggest circle. And we have the radius OU that is drawn to point O, that is the point of tendency of tangent VW with the biggest circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. If VW is perpendicular to UO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So we can actually write down that OU is also perpendicular to tangent VW. OU is also perpendicular to VW. And from these two equations, QU is perpendicular to VW and OU is also perpendicular to VW, we will derive that OQO is one straight line. OQU is one straight line. Or points OQ and U are all located on the same straight line. OQU is one straight line. So we found out that OQU is one straight line. And QON is also one straight line. Again, OQU is one straight line and QON is also one straight line. So from those two things we derive that UN is the diameter of the circle that is equal to 2b. In total, UN must be the diameter of this circle. The diameter of one circle equals to 2 times the radius. The radius is b, therefore the diameter UN equals to 2b. Here the diameter UN is the diameter of this circle is equal to 2b. Okay. So here we joined points O and P together by a straight line. Point O is the center of the bigger circle, point P is the center of the circle. At point S, the smallest circle touches the biggest circle. Again, at point S, the smallest circle touches the biggest circle. And we have rule number 9. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together passes through the touching point. Point O is the center of the big circle, point M is the point of the small circle. Those two circles have internal arch between them at point P, that is to say they are touching each other internally at point P. According to this rule number 9, the straight line that connects their centers together is OM. This straight line OM must pass through point P. That is to say, OMP is one straight line. Or points O, M, and P, they are all located on the same straight line. OMP is one straight line. Okay? So we can implement rule number 9 in our drawing. Why? Because in our drawing, the biggest circle touches the smallest circle at point S. Point S is the touching point between the biggest circle and the smallest circle. So the straight line OP that connects the centers of the two circles together must pass for point S. That is to say, OPS is one straight line. Again, according to rule number 9, OPS is one straight line. Repeat again. OPS is one straight line. If OPS is one straight line, it means that OS minus PS, OS minus PS must be equal to PO. Again, OS minus PS equals to PO. Repeat again. OS minus PS equals to PO. Okay, so OS. What is OS? Point O is the center of the circle, biggest circle. Point S is the point of the biggest circle itself. Therefore, OS is the radius of this circle that we defined as X. The radius of the biggest circle defined as X, so we substitute OS by X. PS is the radius of this circle that is equal to 2, so we substitute PS by 2. So in conclusion, we found out that PO equals to X minus 2. Here, this PO equals to X minus 2 units in its length. Then we extended the perpendicular ON by a straight line. When you extend a straight line by a straight line, the result is a straight line. So OT is a straight line. You know that the sum of the angles on this side of the straight line OT must be equal to 180 degrees. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees, according to the rule that I mentioned. We know that CA is tangent to this circle point M. PM is the radius of this circle that is drawn to a point M, that is the point of tendency of tangent AC. If this circle, whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. Okay, then we draw perpendicular on PM. So here this angle equals to 90 degrees according to our construction. So inside quadrilateral TPMN we have 1, 2, 3 right angles. Therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside quadrilateral MNPT we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So MNPT is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say MP equals to MP equals to NT. Again, MP equals to NT, but MP is 2, therefore NT must be also equal to 2. Likewise, MN must be equal to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. Then we implemented the Pythagoras theorem on the green triangle OPT. On the green triangle OPT, according to the Pythagoras theorem, OP square equals to PT square plus TO square. Repeat again. According to the Pythagoras theorem in the right triangle POT, PO square equals to PT square plus TO square. PO, we have already found out that PO is x over 2, therefore PO square is x over 2 square, and it is equal to PT square. PT is 7 over 2, therefore PT square is 7 over 2 square, plus TO square. TO is h plus 2, therefore TO square is h plus 2 square. So we can find out that x minus 2 square equals to 7 over 2 square plus 2 plus h square. We open the brackets on both sides of the equation and we found out that x minus 2 square equals to x square plus 4 minus 4x, and it is equal to 7 over 2 square. 7 over 2 square is 49 over 4, plus 2 plus h square is 2 squared, that is 4 plus h square plus 4h. Then we join points O and C together by a straight line. Point O is the center of the biggest circle, point C is the point on the biggest circle itself, therefore OC is the radius of the biggest circle, that is equal to x according to our definition. We implemented the Pythagoras theorem on the right triangle ONC. Okay. So in the right triangle ONC, according to the Pythagoras theorem, OC square equals to ON square plus NC square. OC is x, therefore OC square is x square, so x square equals to h square plus NC is 13 over 2, therefore NC square is 13 over 2 square. So x square equals to h square plus 13 over 2 square is 169 over 4. So in conclusion, we found out that x square equals to h square plus 169 over 4. So we can substitute x square here by h square plus 169 over 4. We did it and found out that x square is h square plus 169 over 4 plus 4 minus 4x equals to 49 over 4 plus 4 plus h square plus 4h. So here we have h square on both sides of the equation, so h square will get cancelled. We have 4 on both sides of the equation, so 4 also will get cancelled. And we have to leave with 169, we subtracted 49 over 9 from this equation. We added 4x to this equation, plus 4h. So 169 over 4 minus 49 over 4 equals to 4x plus 4h. 169 minus 49 is 120, so here we have 120 over 4 is equal to 4 as a count factor here, so inside the brackets we have x plus h. 120 over 4 is 30, so 30 equals to 4, inside the brackets we have x plus h. We divided this equation by 2 and found out that 30 over 2 is 15, so 15 equals to 2 times x plus h. We divided this equation by 2 and finally found out that x plus x x plus h equals to 15 over 2. Okay. What is the length of NU? NU equals to U O plus ON. U O is the radius of the biggest circle that is equal to x. ON equals to h according to our definition. So in total U O equals to x plus h. Again, UN, it is actually UN is UU that is x plus ON that is h. So in total UN equals to x plus h. UN or NU equals to x plus h. From one side x plus h equals to 15 over 2, from the other side NU equals to x plus h. But we also, I already showed you that UN is the diameter of this circle that equals to 2b. Repeat again. UN is the diameter of the circle that is equal to 2b. I know that UN is the diameter of the circle that is equal to 2b. From those two equations, we derive that x plus h equals to 2b, and simple, x plus h equals to 2b. From one side, but x plus h is also equals to 15 over 2, so you can write here that x plus h also equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b, we will derive that 15 over 2 equals to 2b. We divided this equation by 2 and finally found out that b equals to 15 over 4. So we found out that the length of the radius b is 15 over 4, and we already found out that the length of this radius of this circle A is 2 units. So b equals to 15 over 4 and a equals to 2. So b over a is 15 over 4 over 2. 15 over 4 over 2 is 15 over 8. So in conclusion, found out that the ratio b over a is equal to 15 over 2, or in terms of numbers, it is equal to 1.875 without units. Okay, thank you very much.